friends, once again welcome for this lecture. Now I would like to discuss about the Werner's theory of coordination compounds. So as you have already studied that ionic compounds are formed by the combination of positively charged ions with negatively charged ions. That means cations plus anions combination gives formation of ionic compounds, and these are simple salts. If we consider double salt, then there is combination, there is mixing, there is addition of one salt with another salt. So this type of combination is called as addition compound or addition double salt. Now different scientists, they have thought about the formation of these complex compounds or coordination complex compounds, and one of them, whose name is scientist Werner, he studied formation of these complex compounds and he has given theory which is known as Werner's coordination theory. So how coordination compounds or complex compounds are formed, it was explained by scientist Werner, right? So we have to see what are his postulates or what are the rules for the formation of complex compounds or coordination compounds. According to Werner, when there is formation of coordinate compound or complex compound, in the structure of that complex compound there are two spheres surrounding to the central metal atom or central metal ion, and he explained these spheres as primary sphere and secondary sphere. If you see the structure of hexamine cobalt chloride, which is a coordinate complex compound, in this structure at the center there is cobalt, at the center there is cobalt, and this cobalt is bonded to 6 ammonia ligands. 6 ammonia ligands, they are bonded with this centrally placed cobalt. So cobalt is a metal part and ammonia, they are present, which are known as ligands. So 6 ligands, they are bonded with metal. So this sphere which I have shown inside, so this is inner sphere. From this inner sphere, cobalt is bonded with 6 ammonia ligand. Surrounding to this inner sphere there is outer sphere, and from this outer sphere 3 chloride ions, which are negatively charged ions, they are also bonded with this centrally placed cobalt. So cobalt is bonded with 6 ammonia ligands from inner sphere, and the same cobalt is bonded with 1, 2, 3 chloride negatively charged ions, and that is from outer sphere. So these two spheres are there surrounding to the centrally placed metal. So this is inner sphere and this is outer sphere. So whatever ligands which are present or which occurs in the inner sphere, this sphere or this valence is called as secondary valence. So inside there is secondary valence, and outside of this secondary valence there is primary valence. So I have shown here primary valence, in which 3 chloride ions are bonded to this centrally placed cobalt metal part. So negatively charged chloride ions, they are bonded with cobalt from outside sphere, and that is called as primary valence. So negatively charged ions, they are bonded with metal through primary valence, and neutral ligand molecules, they are bonded, it is called as secondary valence. So here secondary valence are occurring with the help of which ligands are bonded with metal. So this primary valence or outer sphere is called as ionizable. Why it is called as ionizable? When we take this complex compound and when we dissolve it in solvent, then there will be separate chloride ions. So chloride ions will get detached. That means they are ionized. They are present in the solution after ionization. That means primary valence is ionizable valence and secondary valence is non-ionizable valence, because these ammonia units, they do not get detached from the metal part. So there will be no availability of these ammonia molecules in the solution. See, if we prepare solution, then chloride ions will be there available in the solution, but ammonia will not be separate, or they will not be independently available in the solution. That means this valency or secondary valence is non-ionizable, but primary valence is ionizable. So in this way, cobalt actually, if we think about cobalt, it can show, or it has to show 2 or 3 valence. Naturally it has to show 3 valence, but here the same cobalt is bonded with 3 chloride. That means 3 valence is already satisfied. In addition to these 3 valence, it is bonded with 6 ligands. That means total 9 valence we are looking in case of this cobalt. So why this cobalt metal is showing different valence, that is explained with the help of this Werner's theory. So additional or extended valence of any metal atom or metal ion can be explained with the help of this Werner's theory, that is Werner's coordination compound theory. But still it has some limitations. What are these limitations of Werner's theory? Based on this theory, it is very difficult to explain electron configuration and valence of the metal. It does not matches. So it is very difficult to predict the valence based on electron configuration. This Werner's theory cannot explain magnetic properties of the formed complex. So why these complex compounds, they are paramagnetic or they are dimagnetic? So these magnetic properties are not explained with the help of this Werner's theory. This is second limitation. This theory cannot explain D to D transition. So how electrons are promoted or transferred from D to D orbitals, it is not explained with the help of this Werner's theory. Again, whenever there is formation of complex compounds, all these complex compounds or most of these complex compounds, they are very colored. They have very nice colors. These complex compounds are coordinate complex compounds, they are colored compounds. Why this color is formed, or there is color to complex compound, it is not explained by Werner's. Again, he could not explain geometries of complex compounds with coordination number 4. Why it is tetrahedral or why it is square planar, it is not explained with the help of this theory. And last limitation, some metal atoms or some metal ions, they show different valence. So why they show different valence, it is also not explained based on this Werner's theory. So with these limitations, I have to conclude, though Werner's theory has some limitations, he could explain formation of complex compounds or coordinate compounds, coordinate complex compounds, and that is the success of this theory. And because of this extraordinary talented theory, he could get Nobel Prize. So Werner was awarded, or he was honored with Nobel Prize. Okay, so next aspect of this theory we will see later.